This is a first and only take on the workflow I talked to you about yesterday. This is, I'm using Notepad Plus here on the PC, and I'm editing code which will be converted into TI basic code that we're going to compile. And right now you can see there's some comments here, some variable declarations. I'm using extended basic 256, but my commenting format and the format of the code is, well, I'd say it's modular. It's not your typical basic. There's no line numbers. Here you go. You see some code with my main loop here, and there's no line numbers here. We have labels instead of go-to numbers. And this code, although it's using the TI extended basic and the assembly extensions, which are extended basic 256, as you can see, this code right here draws a title screen. It's portable. I could cut this and paste it anywhere in my code, and it's still going to work. It's not line number dependent. We have labels, and we have modern type commenting built in. Here's a comment right there, put in my code. Now, how did we get this to run on the TI? Well, we just click and select all and copy it, and then we put it into Tidbit. Tidbit's over here on the left, and I'm going to paste that in there. And what Tidbit is a program that converts this code from a modern editor, and it adds line numbers and removes labels. And it does it really quick. Right now we're looking at about 750 lines of code, but with comments about 1,000 lines of code over here on the right. And I just pasted it into Tidbit, and here's the translate button. When I click it, boom, just that quick. I now have label lists and numbered TI extended basic compatible code. See how that is? And we don't have to develop on the horrible TI keyboard, and we don't have to write code unstructured and basic spaghetti code with go-tos and numbers everywhere. So now I'm going to select all of this code, and I'm going to copy it, and I'm going to bring it over to Classic 99. Whoop. And I should have closed that. I'm going to open Classic 99 for you, a new instance of it. There we go. And we're going to load, by typing A, we're going to load the extended basic cartridge, and then I'm going to run the extensions. From disk 2, I have XB256. And the screen will turn gray, and that'll let me know I'm in XB256. Now I'm going to go ahead and paste using the Classic 99 Paste XB option. I'm going to paste everything from my Windows clipboard into Classic 99. And of course it's pasting it in the extended basic format that the TI accepts. If I tried to paste this code in the top left into the emulator, you'd hear all kinds of noises, and it would not take kindly to that. So I'll let this run, and you kind of get a feel. I've seen this pasting run very slowly on a laptop with one of those Atom processors. This is a older PC that I'm using to edit with, so I assume this scrolling, it's faster on the desktop PC I'm using, and I assume that it would be lightning quick on something modern like a i5 or an i7 system. So right now we're up to code line number 3000. And I believe we're about 2/3 of the way through. I talked to you about working on a game. I'm doing that right now. And while that's scrolling, I'll just kind of show you what we have for a system. Over here is the TI. I've got the SD drive from Letheric. I was showing you Miss Pac-Man yesterday. Here's my Flash ROM 99, which is a SD cartridge, or you could put bin files onto it and run it in a TI. And it's my TI test system right here. So got the PEB, the old school brushed aluminum TI with the flash SD drive. Now that I have this flash ROM 99, I rarely use the floppy drives, only for archiving old floppies. And even the Lotharic, which emulates drive 1 and 2, I don't use it as much because I'm able to put my things into flash ROM 99. Okay, here we go. As you can see, my code's been pasted, and I've got about 24K of programmable memory there, and I'm going to type size here so you get a feeling. I'm down to about 2K, so it's about a 22K program that I pasted in there in BASIC. I could save this onto disk 1. Let's see, I'm going to call it Randy XB, and that's the program being saved on the disk 1 in the Classic 99 emulation, and we just saved that program. Now I want to compile the program. I don't want to run it because I know it's going to be slow even in a speeded up emulator mode. So how do we do that? Well, we have to leave extended basic 256 by typing by, and go back to extended basic, and then run the compiler, which is on disk 2. And this is where the Harry Wilhelm magic comes in. This is the extended basic compiler 2.56 by Harry Wilhelm. He's on Atari Age, and his name is Senior Falcon. If I select number 1, it's going to ask me which program do I want to compile, and our program is disk 1. What was it, Randy? I think. Is that what we called it? Output file. Oh shoot, I gotta mess this up. Okay, I got a little bit ahead of myself in that last video, so we're back to the point where we just pasted the program into Classic 99, and I saved the program and I named it Randy XB. I used the old statement to load it back, so you can see we'll list 100 to 190, and you'll be able to see the code right there. As you can see, my comments from up at the beginning of the program, I have my name and address and information like that, and a bunch of variable assignments. Those comments are gone in the emulator. Line 100 is a restore and randomize and option base statement, and if you look down at the Classic 99, those things happen right up here at line 6. So the first 5 lines have been removed by Tidbit, along with every other comment. Every other label has been changed to a line number, and line numbers have been added. So here we are with our extended basic code, and I want to save this program in merge format. So I'm going to save it at disk 1, Randy XB M merge, and what that does is it saves a copy of this program in TI's merge format. Apparently the assemblers and editor assemblers are able to work with listings in merge format easier. Okay, now that that's saved in merge format, I can run Harry's compiler. And I'm going to select I'm going to select 1 actually to compile. Now we want to compile disk 1, Randy XB-M, and I want the output to be Randy XB-S. Runtime routines, that's where's Harry's compiler routines, that's on disk 2. And do I want to proceed? Yes. Okay, now we're compiling. And we are compiling slowly. So what I'm going to do is I'm going to go up here and I'm going to CPU throttle to CPU overdrive. You can see it speeds up the compiler quite a bit. Although this can also be drawn out. While that's compiling, well, I guess I can edit the video so that you don't have to stare at this. But maybe I'll leave it in, what the heck. Okay, it's up to line 3300. It's not too slow. Again, this compiler, of course, would be much quicker if you were running it on a modern PC. I've got a low-powered computer that's about 5 years old that I'm running this on because I'm kind of a Mac guy, so I only do PC out of necessity. Okay. All kinds of magic's going on, and what's happening is the basic code is being converted to something that the editor assembler can look at, kind of like assembler source code. All right, we got that compiled, and now I want to assemble what's compiled. So it says randyxbm has been compiled, and the output file is randyxb/s. So let's select 2. And when you select this assembler, it loads this program called FunnelWeb, which is a Australian editor assembler. Apparently Harry didn't integrated this into his system, but it works pretty good. I'm gonna assemble the compiled program. So I'm going to select number 2 and 2 again for assembler. And it knows the program that I was using, randyxb/s. For some reason it wants to name the object file the same thing, but we're going to change it to randyxb-o. List device name, that's an old TI thing if you want to list it to a printer. And options, I don't know what this does, but they say just use option R, so that's what we're going to do. And then on the TI, it's function 6 to proceed. And here we go with the assembler executing. Again, this is on a slow PC, and it's also a program that's maxing out the size of a basic program. So we're up to like 22, 23K and about 750 lines of code. In fact, I can come over here while this is oh look, assembler executing, and I have 0 errors, which is great. I'm going to press enter to continue. And there is an option 3 for loader, but that option doesn't work. So you have to get out of that program, go back to extended basic, and you have to run Harry's loader. Run disk 2, and he calls it C loader for compiler loader. Okay, it wants to know the name of the file. We have disk 1, we have Randy xb-o, that's the object file name, object code. And now what we're doing is we're taking the assembler object code and loading it into the memory of the TI-99 itself. To me, this is kind of cosmic, this whole process, but it works great. And as soon as we get it loaded, you're going to go from a light blue screen to a dark blue screen with white letters, and it gives you 3 options. It shows you how to save the program so that you can run it directly from Extended Basic. And Extended Basic is, if you leave the cartridge in or you have it on your system, that's kind of the default OS. Okay, here we go. The compiler loader is complete, and up top it says enter file name or loading file. It's loaded. To save it in XBasic format, you could type that. Now let's do that just for kicks. Save disk 1, Randy xb-c. And when I do this, it just saved a program that I will be able to run from Extended Basic. Okay. Now you also have the option to save it in a editor assembler 5 format. This is important because in this format we can convert it to a bin file and we can load it onto the Flash 99 here, put it on an SD and run it directly on a TI system. So there, I'm doing a call load now for EA5 maker, and that's an assembly subroutine that Harry's written that converts what's in memory to a EA5 format. Now I'm going to do call link EA5 and where I want to save the program. So disk 1 Randy XB-A, and that's the assembled code. Okay, that's saved. And to prove that that's saved, we're going to go up to the disk option on Classic 99. We'll go to disk 1 and we'll open it. And let's look at date modified. Oh look, 2/13. We have 3 programs that were modified just now at 1:27 p.m. That's Randy XB A, B, and C. Again, you've got the object code, the source, and also the merge format. So these 6 files, along with Randy XB, these have all been created on the disk here within the last, I don't know, 10 minutes or so, maybe 15, maybe longer. We're going to take A, B, and C, the top 3, and we're going to copy them, and we're going to come down here to the C drive, and we're going to go to Module Creator, and we're going to go to the assembled folder, and I'm going to paste them. So now we have 3 new files in the assembled folder from the 13th. And why am I doing that? Because I'm going to launch the final component of my workflow, and that is Module Creator 2.0. And this is from Fred Krull. I'm not sure the spelling on his name, but he created this deal that converts assembled code to module bin format. So I'm using that Module Creator. I don't really know how it works. All I know is it works great and it's easy. So we're going to make a configuration. We're going to call it Randy XB. We're going to tell it the program name. So we'll call that Randy XB. And we're going to add a program file. And we have to tell the, oh, I'm sorry, up here we add the program file. We tell it, we go to the location, and we find there's Randy XB, and I'm going to select the A file and open it. For some reason, I believe the A, B, and C files have to be in the same folder. And I click Create Module. Here comes some more magic. No errors found. It's using cross assemblers. It's building bin files. And it's just that quick. Even on a slow computer, I just made a bin file. It says push any key to continue. I will. I'm going to reduce Module Creator. I'm going to go back to the C drive and go to the Module Creator. And look, we've got a new folder called Randy XB. It was just created now at 1:30. Double click that and there's your bin, Randy. All right, now we're going to copy this bin and we're going to put it on a SD card. So I got to load up an SD card into the computer. I've got one right here. That's for the flash ROM. I'm going to paste Randy XB bin on there. Now I'm going to eject that SD. I'm going to take the SD and put it right into my flash ROM 99. Plug the flash ROM 99 into the TI. Power everything up. And there's the TI home computer. I'm going to select any key to begin. And look what option number 2 is. That's Randy XB. I'm going to select 2. Flash ROM's going to do its thing, and boom, this is the game I told you about, and it's called Spark Drummers Challenge Rescue at Atari Age. It's about 90% finished, and I'm working on this, and I think what I'll add is a video to show you the gameplay with the compiled version versus the regular extended basic 256 version. Okay, Randy, we're back to the emulator Classic 99. I'm going to go to Options, CPU Throttling, and I'm going to go to Normal. Okay, this is going to show you the normal speed of this program, Disk 1 Randy XB, which I just loaded. I'm going to run it, and this is a game I'm working on, and I'll tell you what, it's so slow in the non-compiled version that it's unplayable in my opinion. And you'll see how slow it is, and what I'm going to do later is show you the video of what it looks like running compiled. So when you're developing something, you have to kind of get it running, and up here in Classic 99 you can select Options and go to CPU Throttle to CPU Overdrive, and you can speed it up quite a bit, but not even as fast as the compiler. The compiler speeding the basic code up about 10 times its normal speed. And depending on your system, CPU Overdrive might do like 2 or 3 times. So here it goes. I'm going to run this, and I want you to take note at how long it takes to load. Now this is typical of the slow, twice interpreted TI basic code. This is why a lot of people left the TI, because it's just slow as molasses. And the better program you write, the bigger program you write, the worse the performance is. So you can write some really simple things and use sprites and graphics and make a really nice program if it's simple. But as soon as you make it complex, it's slow. Did you see the screen drawn? That was really slow. And I'm going to play the game, and on this first wave of the game, you have to take a ship and make it through the maze. Now just be patient with me, because this is not the game I'm actually developing. This is the uncompiled version of it, so it's going to be pretty horrible. Let's make sure I have the volume up for you on the speakers, so you can experience the surround sound. Okay, we got 3 levels here. Even selecting levels can be kind of frustrating. I've got, I'm going to run it on Tercian Grandmaster. Terci is the creator of Classic 99, and this game is, when I finally do release it, I'm kind of keeping it quiet. It's going to be a thank you to all the people on Atari Age that helped me out. So they're all mentioned in the game. Okay, here is level 1, joystick up to begin. All right. I've got a countdown, and watch how slow this is. Okay. It's just horrifically slow. I can barely play it. What I'm trying to do is navigate through this maze. And now I did select the hardest level, and on the hardest level, believe it or not, the doors in the maze move. But you won't see the doors move here that much, because it's just crawling at a twice interpreted snail's pace. This graphic here is animated, and well, that is what a crash is. So I crashed, and you could see that game would not be fun at all. So what we're going to do is we're going to switch over to the actual TI hardware here, and we're going to take a look at the same exact code. This is Randy XB. Kind of a catchy name, huh? And this is running the same exact program, but it's compiled. So you're going to see quite a difference. I'm going to do joystick up to play. All right. Notice how quick the skill level selection can be. Also notice the animation on the ship when we take off here. I'm going to push a button. I'm going to pick Tertian Grandmaster. And there you are, the same screen. Much better game. Here we go. See the walls moving? Okay, I made it through. I'll give you a sneak peek of my game. The idea of it is you travel through the maze, and you've got a little guy down here, Spark Drummer. He's also on Atari Age. He's lost his mojo because he used to be the head of the Phoenix Valley of the Sun users group. One of you guys interviewed him, I believe. Well, he's trapped down here, and he needs his mojo to get up to the ship. So you're flying over the terrain, and I don't know if you noticed, but your route through the maze on the previous screen defines the terrain, and why that's important you'll see is evident coming up soon. Now you go up to find the mojo, and the mojo is that yellow Arizona shape item. You want to get that with your ship, and you want to pick it up. At the bottom of the screen, you now see an exit, and the guy Omega, who's also on Atari Age, is doing his best to close the door before you get out. You can't run into Omega, or you're going to die. You got to get out before it closes, which I just did. Now you're orbiting over Spark Drummer with the mojo. We've got a one-button joystick. Guess what you do? You push the button to drop the mojo, you steer it down, and right now when Spark Drummer gets the mojo, he jumps up a little bit. It takes 5 trips through the maze for him to jump high enough and get rescued by the ship. So that's basically the game I'm working on right now. Again, you saw it played, and here is the anemic TI extended basic code running without any acceleration. This is what it would run like on a TI without compiling the code. And here again is the game. I'm going to do that same crash so you can see the difference. Running on a system compiled. Let's crash on purpose. See if I can get through one more time. I'm going to try to make a long distance crash so you can see the sprite graphics working. Is it much better?